Let us do another good numerical for your JEE Main and entrance examination. The problem is like this. In the figure shown here, a capacitor C1, these are the two plates of a capacitor C1, is rated as 10 microfarad 800 volts. Means its capacitance is 10 microfarad. We can apply at the most 800 volt across it, right? And C2 is rated as 4 microfarad 200 volts. These are the two plates of a capacitor C2. Its capacitance is 4 microfarad and we can apply maximum 200 volt across it, right? That is what the meaning is. What is the maximum EMF of the battery that can be connected shown? Now these two are connected in series. Now here is a battery. What is the maximum potential difference that we can apply here, right? The maximum value of the potential V is called EMF, electromotive force, that you will study in current electricity. But that this is also voltage, the maximum value of the voltage, right, of the battery that can be connected as shown. Now look, this capacitor is rated as 10 microfarad 800 volt. Means you can apply 800 volt across it, and its maximum, and its capacitance is 10 microfarad. So C1 can carry a maximum charge of, if you charge it individually, we know Q is equal to CV. So Q1 is equal to Q1, means for this one is CV, its capacitance into voltage, that is what you can maximum give across it. So this into this comes out to be 8000 microcoulomb, right? C2 is rated as 4 microfarad 200 volt. Means you can, if you consider this individually, this is C2, maximum you can apply voltage across it is 200 volt. This is maximum you can apply across it. Similarly, this means if you connect it individually, you can at the most maximum apply 800 volt, not more than that. But now they are connected in series. So what is the maximum that we can apply here now, satisfying this condition and this condition? Similarly, the charge in this, similarly C2 can carry a maximum charge of Q2 is equal to, using the formula Q is equal to CV. So Q2 is equal to CV, its capacitance 4 microfarad into 200 volts, that is equal to 800 microcoulomb. Because of now, but C1 and C2 are in series, so the charge has to be same. So if you consider this charge, 8000 microcoulomb, this capacitor is happy, but this capacitor is not happy because it can carry a maximum charge of 800 coulomb. But if you apply 8000 microcoulomb, this capacitor will not work. That is not within its limit. So if we consider this 800 microcoulomb, if we consider 800 microcoulomb, because they are in series, this will be happy, and this capacitor will also be happy because this 800 is well within 8000 microcoulomb, right? So we have to consider this one. So 800 microcoulomb is the charge considered for both, not this. This is considered, right? Now we know the charge now. So how much charge we should apply, should go through the series combination is 800. So this is the charge flowing now. Now therefore V1 across C1, potential difference across this by flowing 800 microcoulomb charge will be V is equal to, using the formula V is equal to Q by C. So V1 is equal to Q by C1. So Q, this divided by its capacitance is 80 volt. So across C1, when 800 microcoulomb flows across this, the potential difference is equal to 80 volt, is equal to 80 volts, and this is rated as 800 volt. So this is well within its range, so this will work. Now the V2 potential difference across the second capacitor C2 will be using the same formula, V is equal to Q by C. So V2 is equal to Q over C2, that is 800 microcoulomb divided by 4 microfarad, that is equal to 200 volts. So when this 800 microcoulomb is flowing across this, the voltage comes out to be 200 volt, that is equal to 200 volts, and it is also within the range of it. It is meant for 200 and it is 200, so this will also work, this will also work, right? So so voltage here across is 200 and here across is equal to 80. So the total voltage, so the maximum voltage that can be applied is 80 plus 200 is equal to 280 volts. That is, we can apply 280 volts here, 280 volts here. So both the capacitors will be happy within their limits, right? So you can say this is you can think this way. Suppose this is a bucket capable of carrying 800 liters of water, and this is a bucket capable of carrying 200 liters of water. You can think this way. If you apply 800 liters of water flow through this, so this will be, here it will overflow because that is not within its limit. So the potential difference tells you the limit of it. Means this can withstand maximum 200 volt, this can withstand maximum 800 volt. What should be applied here? So this also works, this also works.